When given a circle, one of the most useful rules that you can memorize for this test is that if you have a triangle inscribed in a circle and two of the vertices lie on opposite sides of the diameter, so here and here, and the third vertex is somewhere along their circumference, and I'll say there, then this triangle is a right triangle. If I draw another triangle using the two endpoints of the diameter as vertices, and instead this time let's say the third vertex is somewhere there, again this is a right triangle. So again, the rule is that this has to be the diameter. Again, for the bottom circle, this is the diameter. If the triangle has two vertices on opposite sides of the diameter, and the third vertex is somewhere along their circumference, it doesn't matter where, just it has to be somewhere on the circumference, then the angle that it makes, where that third vertex touches the circumference, that's going to be a right triangle. So let's actually derive this. So please excuse my bad circles, but let's say that this is the diameter with center C. These are the two vertices on opposite sides of the diameter. And again, I'm going to choose a random point. And please feel free to draw your own circle and your own third point anywhere, again, on the circumference. Now I'm going to break the shape into two smaller triangles, connecting the third vertex to the center. And now I want you to just make up a number for this degree. It looks like roughly 60, so that's what I'm going to choose. Now for this triangle here, since this is a radius, and this is also a radius, we have an isosceles triangle, right? And so if this is a radius and this is also a radius, these two angles must be equal. So those two angles must be 280 minus 60 divided by 2, which in this case is 60 degrees, so it's a equilateral triangle. If this is 60 degrees, then this angle must be 120 degrees. And again, these two angles, using the same logic here, they must be equal, since this is a radius and this is a radius as well. So again, if we have 180 minus 120 divided by 2, we get that both of these angles individually must equal 30. Now if you notice, that angle is 30 plus 60, or 90. Now again, feel free to choose completely different numbers, and let's just run the exercise one more time with different numbers so that you can see it works with any degrees that you choose. Again, I know I kind of made it look like 60, but instead let's say this is 20 degrees. Again, this is a radius, this is a radius, so this is an isosceles triangle, and these two angles will be 180 minus 20 divided by 2, which is 80. So this is 80 degrees, and this is 80 degrees as well. If this is 20 degrees, then this is 160 degrees. And again, we have a isosceles triangle with the radius being the two legs. So these two angles will be 180 minus 160 divided by 2, which is 10. And again, we have 80 plus 10, or a 90-degree angle. So I encourage you to plug in random numbers again. I chose 60 and 20, but you can start really with 2 degrees or even 1 degree, and verify that this rule always checks out, and it should if you do it correctly. So again, the rule is if we have a circle and we have a diameter and a triangle's two vertices lie on either side of the diameter and the third vertex is somewhere along the circumference, then you have a right triangle.